classic question on any graduate student's exam that has had immunology is, what is ADCC? And that's antibody-dependent cell-mediated cytotoxicity. This is basically where you have an antibody binding to receptors on the surface of the cell, especially those like with internal parasites, with schistosomes, blood flukes, helminths, flatworms, tapeworms, liver flukes could stimulate them as well. What happens is the antibody is developed against it. It binds to these surface receptors. The FC region is activated. Especially IgG is really good at doing this, certain types of IgG. And then it binds to the FC receptors on the effector cells, macrophages, natural killer cells, neutrophils, cytotoxic T cells, eosinophils, you name it, and basically it causes them to release toxins in the vicinity of this reaction. Okay, now that can be harmful too. You can get side effects. If you've got a liver fluke and this reaction is occurring in the liver, it's going to damage cells in close proximity to the internal parasite. So you do get some secondary effects going on. But it's in an effort to try to rid yourself of a particular parasite or infection. They're trying to use this in some vaccine development now. So if they can use ADCC to create a monoclonal antibody that will bind to a specific receptor on the surface of, let's say, a breast cancer cell, then the antibodies bind to it, you get cell-mediated responses being produced from ADCC, and you get killing of the tumor cells. Yes, there is a chance at other tissues getting damaged around that vicinity. But if you're using it as a secondary type treatment, it's great because the monoclonal antibodies will be removed from the system pretty quickly. Now, one thing that they would like to do is to be able to produce a monoclonal antibody that is not going to have differences in the stalk or the FC region of the antibody enough that it can be told between the two different species. Is that aloe? Aloe? Does that ring a bell? Okay. Iso, aloe, ideo? Aloe is the one? Okay. So, they're approaching that in two different ways. One, they're trying to be able to isolate white blood cells from the patient and then create the monoclonal antibody that way. That's a lot of work because you'd have to do it for every single breast cancer patient. Or they're trying to isolate the gene from the patient for the FC region of the monoclonal antibody and create some of those hybrid antibodies that can go in and attack the cancer cell. If they can come up with the right PCR protocols, they could set this up and do it. So it would still be a little expensive to do, but hey, if I had prostate cancer, I would be all for it. Take some blood and then give me an IV, and poof, there goes the cancer. So that would be a great thing to watch for. So ADCC has a lot of current applications. You need to read through the experimental assessment of cell-mediated cytotoxicity. There's a lot of good stuff in there. And then that's pretty much it. I mean, read through that last couple of pages, page 367 and 368, and then there's a good summary here, so you can look at those. The next chapter you're going to be on your own is chapter 15.